All right, welcome back. Let's do Leetcode 92, which is reversed linked list 2, and it's a medium problem. And here we're going to deal with some more pointer magic, some more pointer confusion, but we're going to figure it out. You ready? So for this problem, you are given the head of a linked list. So here's our head. And you're also given a left and right index. And basically what you want to do is between the index of left and right, you want to reverse that sublist. So if we look at this index as 1, so this is 2, that's where our left begins, 3, and 4. So we want to reverse this list so that at the end, we will end up with 1, 4, 3, 2, 5. 1, 4, 3, 2, 5. That's how we want to end up at the end. So how can we get started with this? Well, first we can start by using a dummy node. So I'm going to write out some code here, and I'm going to be using JavaScript as always, but feel free to use any language you want and follow along. And I'll say let dummy, once I can figure out how to spell, equal, and this is going to be a dummy node with a next pointed at the head. And we can visualize this really quick with a dummy node. So I will create a dummy node like this. I'll make them yellow, and I'll put a D, big D in there for dummy or whatever you want that to stand for. All right, and let's continue on. So we're going to need to know the previous node, and the previous node, we're going to also point at dummy. Okay, my computer isn't working with me right now. Previous equals dummy. So right now we have a previous pointer, and it's pointed at dummy, right? And dummy's pointed at head. Make sense so far? Now what we need to do is we need to obviously iterate to find where left begins. So what we can do is start a for loop, and we can say for let I equals 0. I is less than left minus 1, and I'll explain why minus 1 in 2 seconds, I plus plus. That opens our for loop. And now the reason we want left minus 1 is because we want to get this node so we can say previous dot next. And we will always know that the starting point is at this node's next. So here we go. Let's do that. So we're going to update previous. Previous equals previous dot next. And now let's go through this loop here. So right now left is 2. So you can think of this as our condition says condition equals 2 minus 1, left minus 1. So 2 minus 1 is 1, right? And we are currently at I equals 0. So we're going to do this live as we go through this. So prev is at dummy, and we're going to say is 0, I is 0 less than 1. It is. So let's increment previous. Now I is going to be 1, and we're going to say is 1 less than 1. It is not. So that's all we have to do for here. So we can break that loop. And now that we're outside of this loop, we can set our starting node, which we know is the next node. So we say start, let's start equal previous dot next. And then we're going to grab a temporary variable. So we'll say let temp equal start dot next. So let's create these pointers now. So we have a new pointer to start, and we have a new pointer to next or temp. And the reason we want this is because we want to be able to swap nodes in a very specific pattern, and I'll explain that pattern to you, and hopefully it clicks. All right, now to the meat of the problem. We need to start reversing. So how do we know how many times to iterate? So what we want to do is we want to set up a new for loop, and we'll call it let j equal 0. J is less than right minus left. I'll explain why we want that in 2 seconds. J plus plus. and we'll open our for loop here. Oh, cursor's not behaving. Okay, perfect. So the reason we want right minus left at this point is because we know where our start begins. And if we look at right minus left, 4 minus 2, we know that it's 2 more nodes, 2 more iterations. So if start is here for 2 more iterations, 1, 2, we now are able to span our entire list. If right was 9 and left was 2, and this list were as many long, it would be 9 minus 2, which is 7, and our span would be 7 nodes we were swapping. So we'd be able to iterate through the entire sublist. So now I'm going to explain an extremely simple pattern to get this done correctly. This is a comment, and we're going to say we want to reroute. I should turn this into like a song so that it sticks. Reroute, then we want to swap previous, then we want to move pointer to next. That's it. We're doing 3 very simple steps. First, we want to reroute. What are we rerouting? We're rerouting starts next. So the first node of our sublist starts next to temps next. So we're going to move 2 to 4. Here we go. So we'll say start.next equals temp.next. That's it. We're done with our reroute. And once we've rerouted the first node, we can then swap 3 and 2. Swap previous. Okay. So let's do this. Let's swap previous. So we're going to say temp.next equals previous.next. Now watch what happens in our wonderful drawing here. Temp.next equals previous.next, which is 2. Here we go. So you can see 3 is pointed to 2. And then to finalize that swap, we're going to say previous.next equals temp. Here we go. So previous.next is equal to temp, which is 3. So 1 is pointed to 3, 2, 4, 5. So you'll see effectively what happens here is like that. 1, 3, 2, 4, right? We've swapped 2 and 3, and all we did was reroute the first node. And once we've done that, now all we need to do is move our pointer to the next space in our sublist, and we'll do that by saying temp equals start.next. Temp equals start.next. So temp equals start, which is here. The next is already pointing at 4, so we could just move temp on over to 4. Now I'm going to move our code here, and we could now visualize this in a new list. What do we think? So let me copy paste this list. And right now we actually have 1, 3, 2, 4, 5. I'll give a couple of new arrows. There we are. And now let's go through it again. So first and foremost, what is important is to note that we already went through this once as a part of the explanation. So at this point, j is 1. J increments, j++. So j is 1. Right minus left is 2. So we can say j equals 1. And our condition for this loop, I'll call this loop condition, is 2. So this is our second iteration. Our first iteration was here, which was 0, 2, right? So if j is less than 2, 1 less than 2, continue on. So let's reroute start.next. Actually, let's pull down our previous pointers. So right now we know temp is at 4. We know start is at 2. It's still the starting node, and previous is at 1. Okay? So let's do it. Reroute start.next is temp.next. Start.next is temp.next. So 2 is going to jump 1. We're jumping, right? That's the reroute. And then what do? We swap the 2 previous. So temp.next equals previous.next. Here we go. Previous dot next. So 4 is going to point to 3. And then previous dot next is pointed to temp. A little longer of a swap this time. And then we're going to move our pointer to next node. So temp equals start dot next. So starts next, 2 goes to 5. So temp is going to move here. Okay. And now our sublist looks like this. Let's do this. Let me unmangle these arrows, right? Our sublist, or rather our entire linked list, looks like, one second, and I'll update these values. So 1 points to 4, 4 points to 3, 3 points to 2. Oh, that's not working. Why are you not updating? One second. Technical difficulties. There we go. And 2 points to 5. Now at this point, we've finished our loop. So J is going to increment 2. And the loop is going to ask, is J less than 2? Is 2 less than 2? It is not. So we're going to break from this loop. And at this point in our code, all we need to do is return dummy.next. Dummy.next. And that'll give us our new list of 1, 4, 3, 2, 5. And that's it. And now to answer a last question, if you're wondering why we had a dummy node, it's because suppose we had gotten an index, a starting index of left equals 1, right? We would need to have access to that first node and never lose connection to the head. That's it. Pointer magic. Thank you.